Hello everyone. In this video, we are going to solve a Smith chart problem. So a transmission line with characteristics impedance 100 ohm is terminated in impedance 50 minus j 200 ohm. Determine the voltage standing wave ratio and reflection coefficient at the terminal load end of the line using Smith chart. So they have given the characteristics impedance as well as the load impedance. So your characteristics impedance for the dissipation list line is R0 or Z0 is equal to 100 ohm, as well as the load impedance is given by 50 minus j 200 ohm. Now we know ZR as well as we know Z0. Now the first step is we have to find the normalized load impedance. So in order to find the normalized load impedance, ZR is given by ZR divided by Z0. So we know ZR is equal to 50 minus j 200 divided by 100. 100 is your R0. So you'll get 0.5 minus J2. So 0.5 is nothing but your RA and minus 2 is your XA. So once you find the normalized load impedance, we have to plot it in the Smith chart. So where RA is equal to 0.5 and XA is equal to minus 2. If XA is equal to minus 2, we have to plot below the real axis. And then that means we have to plot below the real axis, right? So here 0.5 is here at this point. So you have to trace this circle. So where RA is equal to 0.5 and XA is equal to 2. So where XA is equal to 2, you have to mark that point and you have to plot the circle. So this circle. So you have to trace this XA as well as you have to trace this 0.5 as RA and you have to mark the point. Now coming to this step 3, draw a circle with O at origin from the unit circle. So that is your origin. From O, we have to take the radius of OA. So your normalized load impedance is nothing but the point A. From the origin, make the radius and draw the constant S circle. So once you have drawn the constant S circle, so the right hand side, the right hand side where it cuts, where your constant S circle cuts the horizontal axis, just mark it as a point B, and that is nothing but your voltage standing wave ratio. So we can find the voltage standing wave ratio using the constant S circle. Now your step 6 is, so we have to extend the line OA to the point C at periphery. So we know the OA, A is nothing but the point at your normalized load impedance. O is nothing but the origin point. So you have to extend the point to the periphery. So the angle corresponding is the phase angle psi of the reflection coefficient. So if you extend the line to the periphery, so that angle corresponds to the phase angle psi. And now the last step is you have to draw the arc with the radius equal to OA. That is from the origin to the normalized load impedance. You have to take the radius, you have to draw the arc on the lower side of the chart. So if you have drawn the arc, you will get a point D. So that is nothing but your magnitude of the reflection coefficient. So once you find the magnitude as well as the phase angle, you can determine the reflection coefficient. So K is equal to, in the polar form, it is represented by magnitude as well as phase. So 0.82 is your magnitude and minus 51 is your phase angle.